Page 309, question number 3. As a roller coaster trolley with a mass of 600 kilograms coasts down the first hill, it drops a vertical distance of 45 meters from initial height of 51 meters above the ground. If at the bottom of the hill its speed is 30 meters per second, what is the trolley's mechanical energy relative to the top of the hill? Alright, so to start off we need a diagram for this one. So we have our ground level and we're going to have our roller coaster ride. Now at the maximum point it is 51.0 meters above the ground. At the bottom of this, however, it is 6 meters above the ground. So that tells us that our change in height in this case is going to be 51 minus 6, which is going to be 45.0 meters as the height. So we're calculating our energy, that's what we want to use, and our velocity at the bottom is given at 30 meters per second. So calculating our mechanical energy is equal to our gravitational plus our kinetic energy. So gravitational energy will be mgh, kinetic energy mv squared divided by 2. Now for our mass, it is 600 kilograms times 9.81 meters per second squared times our height, which is down 45 meters, so that's going to be a negative 45 meters, plus our mass 600 kilograms times our velocity 30 meters per second squared divided by 2. So plug that all into the calculator, we get 600 times 9.81 times negative 45 plus 600 times 30 squared divided by 2. So measuring with a height 0 point at the top of the hill, we end up with 5,130 joules, or 5.13 times 10 to the power of 3 joules as our amount of mechanical energy. Now for part B, what is the trolley's mechanical energy relative to the ground? So we're going to do the same calculation, so same equation, except this time we're going to have a different height at this point. So I'm going to write our previous answer over here. So from part A, 5.13 times 10 to the power of 3 joules. And I'm going to change out this height. So this time, if we're measuring relative to the ground, we're at a height of 6 meters above the ground. So that's going to be 6 meters. So our calculation this time will be 600 times 9.81 times 6 plus 600 times 30 squared divided by 2 gives us a value of 305,316 joules, or 3.05 times 10 to the power 1, 2, 3, 4, 5 joules of energy. So that is our answer for part B. So it depends where you're measuring your zero, what your value is. When we measure it from the top, we have negative height, which makes for negative gravitational potential energy, which is why it's much smaller. Whereas when we measure from the ground level, we have a positive height, so that adds to our mechanical energy of the system, and therefore we get a much larger value for the mechanical energy.